Assalamualaikum. For this video, we are going to talk about forecasting of unemployment rate in Japan. We are from group 3. And this is our group members. Alif Imran, Muhammad Wabil Lukman, Hemi Hilman, Nurin Batrisha, and the last one is Nurul Shahmina.
For introduction part, unemployment is defined as a state of employment in which people have the desire and capacity to work but are unable to do so due to a lack of job opportunities. Unemployment is caused by a nation's economic structure, and it may be caused by a variety of factors depending on whether the country is developed or undeveloped. Japan is one of the world's most densely populated and urbanized. In July 2021, Japan's unemployment rate was 2.8%, which is extremely low. Therefore, it might lead to inflation and reduced productivity. In this study, the data measured the number of jobless persons as a percentage of the labor force, and it is seasonally adjusted. The entire number of unemployed people plus those who are employed is referred to as the labor force.
Next, problem statement. Due to the COVID-19 pandemic, the world is having an economic shock that affected the rate of unemployment. Unemployment rates that are high and stable have a detrimental influence on a long-term economic growth. People who do not have any job spend less money than people who are employed, resulting in a lower contribution to the economy in terms of services, commodity supply, and produce. Unemployment may have a bad impact on one's physical health as well. Joblessness can bring health problems such as headache, high blood pressure, diabetes, and etc. since it is such a stressful situation. As a result, this research is vital because it allows us to forecast the unemployment rate for the following 5 years and ideally avoid all of the bad consequences that might result in greater issues for the economy and individuals. Some recommendations can be suggested based on this research to help and try to decrease the global unemployment problem, not only in Japan.
Next is the research objectives. Firstly, is to determine the most suitable forecasting model for unemployment rate in Japan from January 2005 until October 2021. Second is to forecast the unemployment rate in Japan for the next 5 years. Third is to study the pattern of unemployment rate in Japan from January 2005 until October 2021. Besides that, we have the research questions. Firstly, what is the most suitable forecasting model for the number of unemployment rate in Japan from the month of January 2005 until October 2021? Second, what is the forecasting pattern of unemployment rate in Japan for the next 5 years? Third, what is the pattern of unemployment rate in Japan from January 2005 until October 2021?
Next, I will be talking about the significance of this study. Unemployment can have many negative impacts on the country. This study is conducted to determine the unemployment rate for the upcoming years. Therefore, to keep unemployment from rising, the government can promote job possibilities that can help the economy, which is in great shape.
I will explain about the scope of the study. This information was gathered from OECD website, and the data used came from Japanese country. In 16 years, this data was collected once a month. The unemployment rate refers to the percentage of the workforce that is out of work. As many mismatch indicators reveal the role of a given mismatch or reallocation component is restricted. Instead, the unemployment rate reaction to business cycles has grown greater and more long-lasting. Deflection and rigidity of nominal wage fall in the discouraged worker effect, growth in non-regular employment, and long-term scare of teenagers' unemployment are all possible reasons for this shift. More efforts are needed to reinforce the safety net for non-regular employees, include the social insurance coverage, and to promote the conversion of temporary position to permanent job. Next, I will be talking about limitation of the study. A few limitations had occurred in conducting this study. First, 14 period was provided to complete the study, which is considered a short time of period to select data, finding the suitable article, analyze and writing the report. Second, some personal issue and internet connection issue make it hard to accomplish work during online distance learning or DL. Lastly, the resources are limited since only little specific article for our headline are available.
Literature review for Holt's method. Data from the Organization for Economic Cooperation and Development showed that Holt's method was suitable to forecast the unemployment rate in Japan. Holt's model is made of three equations that work together to get a final forecast. The first is a simple smoothing equation that adjusts for the previous period's trend in the final smooth value. The second equation, which expresses the trend as the difference between the last two smooth values, is updated throughout time. Finally, Holt's method was used to forecast the unemployment rate, with mean square error being used to compare the model's forecasting ability, MSE. The estimation were made to lower the MSE.
One of the time series forecasting methods, single exponential forecasting, is useful for predicting data with no trend or seasonal pattern. During World War II, Robert G. Brown worked as an analyst for the US Navy and devised exponential smoothing. Brown refined exponential smoothing for discrete data in the late 1950s and created algorithms for trends and seasonality. This approach is now frequently employed in the field of forecasting. However, the choice of smoothing constant has a significant impact on the accuracy and control of the exponential smoothing approach. The forecasting approach is improved when the smoothing constant is chosen correctly. The constant value should be chosen in such a manner that prediction mistakes are minimized. The smoothing constant you choose may have a big impact on how responsive your prediction is to past data. When the constant is low, which means the prediction will be less sensitive to the observation than typical. Short-term forecasting, generally 1 month, is done using the forecasting technique. As a result, choosing an acceptable value for the smoothing constant is critical for the successful use of this approach. The value of the exponential smoothing constant determines the accuracy of this method. Constant value should be selected to improve prediction accuracy. Forecasting error, which is the difference between actual and expected demand, is used to assess forecasting accuracy. The objective of this study is to find the constant that reduces prediction error to the smallest amount as possible.
Next, for the double exponential smoothing method. This method is often used to analyze data that contains trend with no seasonal component. This method is one of the popular methods to be used for economic research. Therefore, using a double exponential smoothing method was suitable for this research by using the data and employment rate in Japan provided by the Organization for Economic Cooperation and Development. Double exponential smoothing method update the trend component for each observation. This technique simulates dynamic gradients. A new parameter beta is included in double exponential smoothing to the model trend. Beta, like alpha, can range from 0 to 1 inclusive. Higher values give recent observation more weight, allowing the trend component to react to changes in the trend quicker. Forecasts for this approach vary at a consistent rate equal to the trend component's final value.
I will talk about moving average for literature review. Important to know how to estimate market trend, perform price assessment, complete financial evaluation, and participate in stock market operation using forecasting methodologies. Professionals may use simple moving average forecasting to provide price pattern for commodities over a certain time period. You can make crucial business choice or improve your personal talent by learning how to utilize and compute simple moving average. It is critical for individuals working in financial or economic. Moving averages are totally adjustable indicators, meaning that an investor may compute an average over whatever time period they choose. The narrower the time span used to compute the average, the more sensitive it is to price change. The average will be less responsive over a longer time of period. To perform moving average model, the arithmetic mean of a collection of number over a particular period of time is determined. To put it another way, a group of number, or in the case of financial instrument, prices are added together and then divided by a number of prices in the set. It is possible to compute it for any time of period. Moving average model is used as a benchmark mode for forecasting and unemployment rate. The finding reveal the job opening related model outperform the benchmark model and unemployment insurance in terms of predicting capacity. Moving averages are used to identify whether a security momentum is changing, such as rapid downward or upward movement. They also utilize moving averages to substantiate their concern that a shift is taking place.
Next, I will be talking about the naive method. So, the naive method approach is an estimating technique in which the actuals from previous period are utilized as a prediction for the current period without any revisions or efforts to establish causative components. Its main purpose is to compare forecasts generated by more sophisticated methods. Because the naive forecast is one of the most basic forecasting approaches, it is an excellent baseline against many better models that are routinely evaluated. However, changes in the actual numbers are quite sensitive to this method. A large decrease or increase in the values will have a significant impact on the projection. However, the naive forecast method produces an accurate medium to long-term projections. Next is about understanding on the data. So, for this study, 202 data were obtained from Organization for Economic Cooperation and Development official website. The information was gathered monthly from January 2005 until October 2021. The data is about unemployment rate in Japan. The data is then analyzed using quantitative forecasting such as naive models, methods of averages, and exponential smoothing techniques. For data partition, the total number of data, which is 202, was divided into two parts, which is the estimation and evaluation. The data was divided according to a 70 to 30 ratio, where 70% of the total data is for estimation part, while another 30% is for the evaluation part. All the data will be used to evaluate the model's forecasting performance.
In Brown's method, only one smoothing constant is used, and as such, the estimated linear trend values obtained are sensitive to random influence. To fix this problem, Holt's two-parameter method was introduced. This technique can smooth the trend and the slope directly by using different smoothing constant, but also provide more flexibility in selecting the rates at which the trend and slope are tracked. So here is the application of the Holt's method. Requires three equations.
Next, we will proceed to single smoothing method. The advantage of this procedure over moving average is that it is considered the most recent forecast. It is the simplest form of model among all the exponential smoothing technique. The model needs only one parameter, that is the smoothing constants, alpha, to generate the fitted value and hence forecast. The forecasts for the next and all subsequent period are determined by adjusting the current period forecast by a portion of a difference between the current period and the current actual value. As you can see here is the formula for a single smoothing method.
Next, for the double exponential smoothing. Double exponential smoothing, also known as Brown's method, which is useful for series that exhibit linear trend characteristics. The advantage for this method is its ability to generate forecasts. The application of the double exponential smoothing requires four equations, and the equations are shown in the slide.
Next, for naive forecast, this model assumes a strong deterministic relation which states the current event will determine the future outcome. Besides that is the naive with trend forecast, so this model can be used even fairly with short time series. Insufficient data would prohibit the application of sophisticated modeling techniques. This model is highly sensitive to the changes in the actual values.
Next, I will explain about moving average. In our study, we use three types of moving average, that is, average mean forecast, average change model, and average percentage change model. Next, I will move to average mean forecast. Where there is no discernible pattern, a significant drop or growth in the historical time series, the mean forecast method performs well. This concept assumes that the forecasting value is equal to the average value of the data series over the historical data collecting period. Hence, wherever a new observation is obtained and added to the existing series, the forecast value must be recalculated using this method. So that is the formula that we use. For the average change model, is frequently used by organizations because of its durability and applicability. It is based on the assumption that the forecast value is equal to the current period actual value plus the average of absolute change up to the point in time. Next, I will move to average percentage change model. Average percentage change model is used to measure in the relative term. It assumes that the forecast of the dependent variable in the current time period is equal to the actual level of the variable plus the average of the percentage change from one time period of the next.
The linear graph shows the actual value for the unemployment rate in Japan from January 2005 until October 2021. The pattern of the data shows alternately increase and decrease year after year. It shows that the lowest unemployment rate in Japan was in May 2018 and December 2019. The graph shows the Holtz method outcome about the actual and fitted unemployment rate in Japan from January 2005 until October 2021. For the fitted value, the graph shows that the unemployment rate is increasing and decreasing alternately every year. The fitted line from January 2020 shows the unemployment rate in Japan is the lowest, which is 2.2102.
Next, we will proceed to the result for single exponential smoothing. The graph shows that the actual and fitted value of the total unemployment rate from January 2005 until October 2021. For the fitted line, the graph shows that the total unemployment rate is increasing and decreasing alternatively every year. The fitted line in August 2009 shows that the unemployment rate in Japan is the highest, which is at 5.4593. Agriculture and forestry, building, manufacturing, wholesale and retail commerce, as well as personal and recreational services are all the lost jobs in August 2009. According to the Bank of Japan, the employment and income situation are still dire, although the severity has decreased somewhat. According to the data from Labor Department, the unemployment rate fell by 70,000 or 2.1% from the previous month to 3.34 million in August, following a 60,000 drop in July.
Next, moving on to the results for double exponential smoothing. The fitted line in this graph shows that the unemployment rate in Japan increasing rapidly from 2008 until 2009, and the unemployment rate starting to slowly decrease from 2009 until 2019. The fitted line in July 2009 shows the highest rate of unemployment rate, which is 5.5841.
Next, based on the graph, it shows the naive forecast outcome. Also, it shows the actual and fitted for the unemployment rate in Japan from January 2005 until October 2021. One of the reasons that unemployment rate in Japan increased is that a renewed drive to restore the banking system's health by addressing the problem of non-performing loans resulted in a round of financial restructuring that temporarily pushed the unemployment rate to 5.4%, the highest percentage ever recorded during the decades under consideration. However, the work situation improved once the debt problem was resolved. The subprime mortgage crisis in the United States triggered a global financial disaster and ushered in a global recession. For the fitted line, the graph shows that the unemployment rate in Japan increasing and decreasing alternately every year. The fitted line in August 2009 shows the rate of unemployment is the highest, which is 5.50%. Next is the knife with trend forecast outcome. So, for the fitted line, the graph shows that the unemployment rate in Japan has been decreasing since August 2009, as one of the reasons that is because even with the coronavirus affected the country's already debilitated economy, a combination of social demographic variables has kept the unemployment low. Besides that, under the Prime Minister's leadership, the Japanese government will initiate and sustain massive fiscal stimulus initiatives, which will be a key contributor to that decrease. Higher public works expenditure, certain small company subsidies, and increased military spending are all part of the 10.3 trillion yen stimulus package proposed in the first major budget statement. The fitted line in August 2009 shows the rate of unemployment is the highest, which is 5.817%.
Now I will proceed with average mean forecast for the graph. From the graph, we can conclude that they depict the actual and fitted unemployment rate in Japan from January 2005 to October 2021. The fitted line in the graph illustrates the Japan overall unemployment rate, which is 3.6965. Before 2014, the unemployment rate in Japan is significantly higher than the average. This is because unemployment can result from a drop in demand, which causes business to lay off people. It can also be a consequence of a mismatch between employees and business, such as too many alternatives and not enough physics in each location. The unemployment rate dropped significantly after 2014. This is owing to Japan's extremely low unemployment rate in other nations. The fact that it has been low for a year will worry most economists. I will proceed with average change model for the graph. The graph depicts the actual and fitted value unemployment rate in Japan from January 2005 to October 2001 as shown in the graph. The graph illustrates that the total cases are growing and falling alternately every year for the fitted line. In July 2009, the fitted line revealed the total cases are at all-time high of 5.7. Additionally, the job-to-application ratio has decreased significantly since 2008 because of the fast development of employee adjustment, which include the termination of dispatch and non-regular worker employment contract. Under such conditions, empirical research on the determinant of employment and unemployment in Japan have made tremendous progress from a theoretical economic perspective. This practice was maintained till July 2009. In May 2018, the fitted line indicate that the total instances are at their lowest at 2.05. For the average percentage model, the graph shows actual and fitted unemployment rate in Japan from January 2005 until October 2021. The fitted line in the graph shows the unemployment rate in Japan is increased and decreased alternately every year. A fitted line that deviates from the data line is depicted in the graph. In September 2009, the fitted line indicates that the overall number of cases at its peak, with 17.5318. However, the effect of declining employment on unemployment may be minimized by economically active population highly cyclical character. This tendency may be exacerbated by the fact that a sizable number of employees who leave their job are non-regular employees who get little unemployment benefit and hence have nothing to gain but registering as jobless. In addition to the anticipated decline in the wage bill might exacerbate the Japanese growth model imbalance.
In this evaluation part, 30% from the data are used to determine the error value for each of the models. The last value for each of the models is shown on the slide. As we can see, the most suitable model to use for all mean squared error, root mean squared error, and mean absolute percentage error is double exponential smoothing because all of the error measured have the lowest value.
Next, forecast value. To calculate the forecast, we use the best model that we gain from the evaluation table. The graph on the slide shows that the actual and fitted value for the unemployment rate in Japan for the next 5 years. For the fitted line, it shows that the unemployment rate in Japan increased from 2008 to 2009. The increase of the unemployment rate in 2009 is because of the most companies had to reduce their recruitment and pay off more than 10,000 non-permanent workers. Most of the firm that loses employment is from small and medium-sized enterprises. Research shown that 87% of the unemployment are widely from the manufacturing and the construction. Then, the unemployment rate started to slowly decrease from 2010 to July 2020. The rate from August 2020 to December 2020 slightly increased, mainly because of the coronavirus outbreak, and the rate started to decrease. Next, the focus value shows that the rate is decreasing from 2022 to April 2025. Lastly, the rate remains constant from April 2025 until October 2026, which is 2.6502.
So for the last chapter, we will be talking about the conclusion. As a conclusion of this analysis, the first objective, which is to determine the most suitable model to forecast the unemployment rate in Japan from January 2005 until October 2021 by using 8 modeling techniques, is achieved. The best suitable model that fits the data of unemployment rate in Japan is double exponential smoothing, which has the lowest value for mean square error MSE and root mean square error RMSE. Next, the objective of this study is to forecast the unemployment rate in Japan for the next 5 years. The best model to be applied in forecast future value is the double exponential smoothing model, which has the lowest value for mean absolute percentage error MAPE than the other models. For the last objective, the pattern for the unemployment rate in Japan from January 2005 until October 2021 is also achieved. This trend of the graph, the line is increasing and decreasing alternative every year.
After researching about, there are a few suggestions that should be truly considered in order to enhance this article. One of the suggestions that might be made is to select the most acceptable forecasting technique. The most suitable forecasting model for unemployment rate in Japan, the average percentage model is the least acceptable model because it has a large rise in data and not ideal for forecasting. As a result, alternative forecasting methodologies should be used to draw comparison. The following are some recommendations following Japan unemployment rate. Company must increase production in order to minimize Japan unemployment rate. This not only lower the unemployment rate in Japan but also boost a company profit margin. This should be applied not just to huge corporations but also to develop a small and cottage enterprise. Next, companies in Japan need to reduce the age retirement. This is helpful for fresh graduates to get job opportunities. This can help the unemployment to quickly get a job and in turn reduce the unemployment rate in Japan. Furthermore, full and more productive employment is a proposal that may be made. The primary goal of the county employment policy should be to enhance job possibility and labor productivity. The government should implement a program that ensures that everyone has a job. This is beneficial because some government can make full use of employees who are willing to work without having to worry about a labor shortage.